Hey guys, welcome back to my YouTube channel, Biomathematician. Today we will be discussing about median. Median is a measure that is used to describe the central tendency of a data. Median is the 50th percentile of the given data. That means that it divides the dataset into two equal halves. Half of them are below the median and half of them are above it. Median can be calculated by organizing the data in an increasing order and selecting the central value. If the number of observations is an odd value, then it will be n plus 1 divided by twoth observation. Whereas for an even number of observations, it will be n divided it will be the average of n divided by tooth and n divided by tooth plus 1 observation. For performing all the analysis, we will be using a standard package of Python, NumPy. NumPy is the fundamental package for scientific computing in Python. Apart from NumPy, we will also make a user-defined function here, which I will explain later. So let's begin by installing NumPy. For installing NumPy, we just have to type this command: pip install NumPy. So in my system, it is already installed, so it will give this message. So for the dataset, we have the blood glucose value within a list. This is just dummy data for experimentation purpose. So before going forward, we first understood the indexing in Python. So Python uses zero-based indexing, meaning that the index of the first element is 0 and the second element is 1 and so on. So let's see. We have to run this. Run. So I have arranged the data in an increasing order, and here is the index. So for example, we can see that the first index is 0 instead of 1. So we have to keep this in mind. So for the above equation we have explained, n divided n plus 1 divided by tooth observation will be equivalent to n minus 1 divided by tooth observation in Python, as n divided by 2 will be equivalent to n divided by 2 plus 1th observation, and n divided by 2 plus 1 will be equivalent to n divided by 2th observation. So we have to keep this in mind while defining our own function. So we have a function here, find median. So what I have done here, I have first sorted the data in an increasing order and found the number of samples by using the len function in Python. Then if for even number of for finding even number of samples, we have used the modular division. So if it will be totally divisible, then it will give the remainder, which should be 0. Else, and if it will be 1, then it is an odd number of samples. The number of samples are odd. So for that, we just put the above defined equation, this one, in the formula here, and we define a function. So let's find the median. Median. So according to our user defined function, the median should be 110. Let's see. Let's do the same with NumPy. For that, we first import the library. So in Python, we have in Python, NumPy have a predefined function, that is median. So we will use this lp.median, and we will just give our data here. So using this function, we get a value of 110.0, which we have got from the user defined function also. Apart from the median function, we NumPy have another functions for predefined function also, which we can use, that is percentile. So that is np.per percentile. So we give our data here, and then as we know that the median is the 50th percentile, so we will give a 50. As we can see, that same result is here also. So we can use any of the two functions, np.median and np.percentile also based on our uses. So median, uh, let's see what will be the effect of outliers. As we know that median is less uh, sensitive to outliers, so as compared to mean, but it is still sensitive, but it is less sensitive to outliers. So we have a data here. We have 250 as the outlier. So we can see that mean without outlier is 109.45 and mean with outlier is 121.17, which hence having a difference between the two values more than 10. Whereas for median we can see that without outlier it is 110.0 as we see earlier, and with outlier it is 115. So with the median, the fluctuation happen is just 5, difference of 5. So median itself is very useful measure for several advantages, but it has some limitations also. Uh, Still, it is less sensitive to outliers, but it is sensitive to outlier, as you can see here also. And median does not consider all the data points. As you can see that it only consider for this example, it only considers the fifth data point, that is 110, and it doesn't provide the insight about the spread of the data. Whereas for while calculating the mean, we can calculate the standard deviation. They combine both mean and standard deviation to explain the whole data. We cannot do that for median. So this is all about median. Thank you.